Okay, good morning, pre-AP Chemistry. So some of y'all are saying that you still don't understand scientific notation. So this is breaking it down a little further. The first video I did, we talked about steps. And so I'm gonna go back and forth with a few of them, and hopefully this will help clarify some things. So scientific notation is just a different way to write the same number. So we're not changing that number, so we wanna make sure it's the same. The first thing that we have to understand is that whenever we're doing scientific notation, we're just multiplying it by 10 to move that decimal. So you know that like 20 is 2 times 10. And the only difference between 20 and 2 is that you have your decimal over one place. And so it's a multiple of 10. And the same whenever we go to 100 or 200. So I'll show you what that's looking like here first. So if I have 2 and I multiply it by 10, I'm gonna get 20. Okay, and the difference between 2 and 20 is just where that decimal place is at. It's just 1 over. And if I had 20 and I multiplied it by 10, I get 200. And the difference between 200 and 20 is just, again, that decimal place moves one place over. So every time we multiply by 10, we're moving that decimal one place over. So hopefully you can see that. And the same would be true if we divided. So if instead I took 200 and I divided it by 10, it would be 20. And if I took 20 and I divided it by 10, it would be 2. And so we're just moving that decimal back and forth because it's just by a factor of 10. And so that's why we have that times 10 to the. And so if something is multiplied by itself, so if I went from 2 to 200, I'd be multiplying by 10 twice. And so if we're doing the same thing twice, so just like x times x is equal to x squared, 10 times 10 is equal to 10 squared. And if I had 3 of them, it would be to the cubed, to the third power. And so that's what we're doing. That's why we do that times 10, and that's why we count how many decimal places over we move it. It's because that's how many times we actually multiplied by 10. And so I have an actual example that we'll work out and we'll break down a little bit for you. Ignore the double chin. Okay, so here's 3,000, and we're gonna write it in scientific notation. We're gonna do it 2 different ways. We're gonna do it a slow way, and then we're gonna do it a fast way. So we're gonna divide it by 10. And so we're gonna count how many times we divide it by 10. So when I divide it by 10 the first time, it's going to get me 300. And if you're not sure, put it in your calculator. 3,000 divided by 10 is gonna get 300. So that means we have divided by 10 successfully one time. And so then now I'm gonna take 300, and I'm gonna divide it by 10, and now I'm gonna get 30. And I'm gonna keep doing this until I get a number between 1 and 10. And so now I'm going to take 30, and I'm going to divide 30 by 10, and I'm going to get 3. And 3 is a number between 1 and 10. And so how many times did I have to divide by 10? I had to divide by 10 3 times. First, second, and third. Okay, and so then if I were to consolidate that and make my life easier, 10 times 10 times 10 is equal to 10 cubed. So we can say 3 times 10 cubed is going to be 3,000, because 10 cubed is going to be 1,000. So hopefully that's making sense how we're getting that. Now the faster way to get to this answer is to look here and say, well, here's my decimal. I want to move it to make it a number between 1 and 10. If I just move it once, it's 300. If I move it a second time, it's 30. And if I move it a third time, it's 3. And so then I'm going to say 3, because that's a number between 1 and 10. And then times 10 to the third power, because I moved it 1, 2, 3 times. Okay, so either way we get the same answer, but that's why, that's how it works. So hopefully that's making sense and breaking it down for you. We always want it to be a number between 1 and 10 because that makes it the easiest number. Those are the smallest numbers we can get without going into decimals. And so we want to make sure that we always have one number here, one number to the left of the decimal. And so that's kind of how we do it. Hopefully that's making sense. And we can work backwards and we can do the same thing, but with scientific notation. So if we come over here, You should be able to see it. Oh, it's a little bit of a bad angle, but that's okay. So we have this 4.5 times 10 to the 5th power. And so if I want, I can undo that. And there is 2 different ways I can undo it. I can continually to multiply. So times 10 to the 5th power is the same as saying 10 times 10 times 10 times 10. That's 1, 2, 3, 4 times 10, 5 times. So I could take 4.5 and I could multiply it by 10 5 times. And I can put that in my calculator. I can even do it one at a time. So I could say this one would make it 45, right? If I multiply by the first one. And then if I multiply by the second one, it's gonna make it 450, right? Because 45 times 10. And then if I multiply by the third one, it's gonna make it 4,500. And now I'm on to the fourth one. And I can go that way and I can do that. I'm gonna get the right answer that way. And so, but I want you to realize what is the difference between each of these numbers? Just one more 0. The decimal place is just moving over one time. So now it's here, now it's here, now it's here, now it's here. It's moving over with each one of these. And so the last one will be 4, 5, and then we have 1, 2, 3, 4 zeros behind it. Okay, so we could do it that way, or we could just say, hey, I know that times 10 means I'm moving my decimal, so I need to move my decimal 5 places. And I'm gonna move it 5 places this way because I know this number needs to be a big number because that one's positive. So then I can just write 4.5, and I can move my decimal once, twice, 3 times, 4 times, 5 times, and my decimal's gonna go right here. Guess what? Where each one of these loops are, if there's not a number, there goes a 0 there. And that's the same answer that we got previously. And so now our new answer, our number, now that we've moved it, is that, which is the same thing. So hopefully this is helping you connect a little bit of why we write those numbers, the why part, because I've explained the how, and so now's the why. And hopefully that helps you figure it out a little bit better. I can do another video over negatives. Negatives, it's the same concept, it's the same thing, just you're moving the decimal in the opposite direction. Remember, if this number is a positive number, that means that this number is really big. And so how this is a 5, guess what? 450,000 is really big, right? I'd love my bank account to say that. And if we have a negative, it's really small. That means it's decimals. You're moving the opposite direction. So hopefully that helps you out a little bit for those of you still struggling with scientific notation.